Okay, today we are doing practical number 6, surface interpolation, and today we are going to do a case study to understand the interpolation method. And I assume you have already learned what is interpolation from the GIS lectures. So for the simple term, known values from points are used to estimate an unknown values in a surface surrounding points. That is the simple term of interpolation. So interpolation can be used for commonly for raster operations like estimating elevation, rainfall, temperature, and there are several interpolation techniques like IDW, Kring, and Spline. So for this practical, we are going to use IDW as for the method. Okay, the case study. So a group of residents living in the Pattivila North, Pattivila South, and Mabima West GN divisions of Biyagama Divisional Secretariat have launched a complaint to the Ministry of Health regarding poor drinking water quality due to effluent discharge from the surrounding industry. To investigate this issue, a group of scientists were assigned, and as a result, several water quality parameters of both groundwater and surface water were collected. Due to inaccessibility, only a few data points were considered during the analysis. It is your task to determine the groundwater quality parameters to the entire study area, Pattivila North, Pattivila South, and Mabima West GN divisions through an interpolation method. So this is the data table that you have given. These are the sampling points, and these are the values that collected points, salinity values, sodium, chlorine, and oil and grease. And the sampling locations are given in a KML file directly from the GPS. I will show you that. So these are the sampling points, sampling locations. Okay, now open Arcgis software and define coordinates. For this practical, we are going to use SL grid 99. Click OK. Okay. First step, we are going to extract our study area. So navigate to the practical data 6 folder. And add SLGND shapefile. Right? This is the Gram Niladhari divisions of Sri Lanka. Now we have to extract Pattivila North, Pattivila South, and Mabima West from this map. So now you know a method to select data, right? So first, go to selection on the main menu and select by attribute. From this display, so we are looking for Gram Niladhari divisions, right? So go to GNDN. GNDN means Gram Niladhari divisions name. So double click on it, and we have 3 different divisions to select. So we will use the ind command, then open brackets, get unique values for the Gram Niladhari divisions. So the first one is particular node. I will type in. Yeah, particular node. Double click and add a comma for the next one. Particular south. And again add a comma. And the next one is Mabima West. Double click. So this is your equation. GND in within brackets particular north, comma particular south, comma Mabima West. Click apply. You can see there's a selection is created. Now I want to extract this selection. To do that, right click on the SLGND shapefile. Now you know how to do that. Go to data and select export data. And navigate to your practical 6 folder and rename it as study area. And click save. Add this to your map layout. So now you can remove this GND file. So you have the study area. This you can label it and see if you want. Change the label field. Go to properties. Go to labels and I will change it to GNDN. It means the name of the Brahmaniradali divisions. Click apply. Okay. So you can see particular north, particular south, Mabima West. These are our study areas. Next, the scientist given us the GPS points. So as I said earlier, GPS points were given as a KML file. So in early practicals, you know how to import a KML file to GIS, right? To do that, go to Arc Toolbox and under Conversion Tools, select from KML and KML to layer. Double click on it. And the input feature, navigate to your practical 6 data folder. The sampling points KML is given, right? This contains the 7 sampling points that were collected. So click open. Then output location, I will save it in the practical 6 folder. And I will name it as sampling points. Click OK. Okay, now our sampling points are converted to GIS. We have to insert these values into our attribute table. So this points shapefile has an attribute table, but there are no values. So what we are going to do is go to the table menu and select add field. And first we are going to add salinity. And remember the type is float. As it is going through decimal values, you have to select the type float. Then click OK. Likewise, you have to create 4 other fields for other water quality parameters that are given in this table for sodium and fluorine and oil and grease. After that, you have to add data for this table, but you cannot just add this. First, you should start editing. Okay, So go to your editor toolbar. If it is not there, go to Windows. Sorry, go to Customize, Toolbars, and select Editor. Then go to your editor toolbar and start editing. And we are going to edit the points shapefile. Click OK. Click Continue. As you can see, now you can enter values. So first I will enter the salinity values. I will just copy and paste this. Next, repeat the same steps for all other water quality parameters. And after finish, just save your edits and stop edit. So I have already entered my data, so I will remove this file and I will open the previously I have entered this data to this file, right? So your table will look like this. Salinity, sodium, chlorine, and oil and grease. These are the values you have entered. So now we are ready. We have the site name and the GPS locations, and we have the data. So now we are going to do an interpolation. So first we are going to create an interpolated surface for salinity using IDW tool. So navigate to Arc toolbox and under spatial analysis tools and go to interpolation. As I said, there are tools IDW, Kring, and Spline. So we are using IDW. Double click on IDW tool and input feature is our point feature. Z value means the field that we are going to use for the interpolation. So this time is salinity. So select salinity. And output raster, you can save it as salinity. Then output cell size, change it to 10. After that, go to environments, click the environments button, and here you can see environment settings. So first change the output coordinates. So we will select same as display. Then go to the next settings, processing extent. Processing extent, we will select the study area, because we want the interpolation map to the whole study area. That's why processing extent is used. And the next one, under raster analysis, study area as the mask, right? Then we'll click OK. And again, click OK. So you will get an output like this. You have to drag this to the top, right? So I will show you why we should change these environment settings and why are those important. So I will first uncheck this salinity interpolation file and repeat the same process. I will go to the IDW and select data points and set value field salinity and output cell size 10. So first go to environments, and only this time I will change the output coordinates. I will select it as same as display. Again, click OK. Okay, so you can see what's happened. Without the setting, the interpolation map is created only for the sampling points areas. You can see that. That's why we use processing extent. So I will quickly adjust these settings. I will remove this one and again go to IDW, select data points, select salinity as for the set field, 10 for the output cell value, and environments, output coordinates same as display, and processing extent same as study area. Now I am not going to change the raster analysis masking, just leave it like this and click OK. Now we'll see what will happen. Okay. Now you can see that I can drag this study area to the top and make it. So we have extended our interpolation map, but it's beyond the study area boundary. So we have to clip it, right? But clipping is for vector data. For raster data, we use a tool called masking tool. So you cannot just select this clip tool and select this raster data. It won't show here, right? So that's why we use mask. Now next time I will use the mask. I am repeating these steps because you to get a good understanding what is happening with these settings change. So output coordinates, same as display, and processing extent, study area, and the final one, raster analysis. Masking means clipping. I will clip it to the study area. Then click OK, and you will get this salinity map, right? Okay, now using identify tool, this is the identify tool. You can just click on any location or any point pixel on this map and you can get the results window. In that, it showed the pixel value is 0.0.6. It means the salinity level is 6.06 in this point we have selected. So I will try another point. As you can see, it changes, right? Right? Now we will change the classification and symbology. So first right click the salinity layer and go to properties, go to symbology and select classified, and you can change the how much intervals do you want to classify these layer. So first try to select 5 and make a color ramp as a graduated color. It's better. Then click apply. Now you can see there's 5 clusters in the legend, and the colors are graduatedly getting darker with the highest salinity. In this classify, if you click on this classify button, as you can see, this is there's manual, equal, like that. There are several methods you can classify these data. The machine used automatically equal interval classification. So if I change the classes data 10, then it will divide equally into 10 clusters. There's another option called manual option, and first you have to decide how many classes. Then go to manual option. We can change the break values as we want, so that these values will be adjusted. Okay. Now click OK. Leave the classes to 5. Then click OK. So this is the interpolation map of salinity based on the data given by the scientist. So you have to repeat the same procedure for all other water quality parameters and export 4 maps with proper layouts. You should add titles, scales, map legends, no arrows should be included. And at last, try to produce a map displaying all the water quality parameters in a single map layout. And I will show you how to do it. Go to map layout view. And you can so there are 4 water quality parameters. So we need 4 frames, right? So I will just resize this, and you can simply just copy and paste, right? You can get 4 of them aligned, but remember you have to change the layer as for the frame. This is for the salinity, so this one will stay as salinity, and you can insert the legend here. And for this one, assume you created a layer called sodium, so it will go here with a different color. Likewise, you can create another 2. Because of this same layout, you just need only 1 north arrow and 1 scale bar, right? And the title you should decide, like water quality parameters or something like that, in this areas like that. And remember that you don't have to put 1 by 1 scales for each, because these all are in the same frame sizes, right? Assume like this one is smaller. I will zoom out like this. Then the scales are wrong, right? So all should be in an equal proportion. So that's it. Okay, thank you very much.